to discuss about assembly line automation specific, how assembly line has been evolved over the past few years, and what are the technological advancements in assembly line automation which has come, and specifically three major use cases we have picked up on for assembly line automation. And we can quickly go through or discuss upon what is that particular three use cases and how we can implement that assembly automation in those for those particular use cases, and then benefits, and then have a quick video demo also so that we can discuss on the same. So with this introduction, I'm just going into the session. So this slide shows about the Industry 4.0 revolution, how it has evolved from the beginning. So initially started with the first industrial revolution, where the steam power and water power systems has come into existence. That is long way back in 1800. And then slowly the industrial revolution moved on to the second generation, that is second industrial revolution, where mass production assembly line came into existence. That is in the early 1900s. And then we moved on to the third industrial revolution, that is computer and automation, where computers and IT came into existence and how that impacted our manufacturing and assembly lines. And then currently we are in Industry 4.0 revolution, where we are speaking about cyber physical systems, how machines interact with each other, machine to machine communication, and how the data from various machines can be captured easily, and how those data can be used for our day-to-day activities and to derive more valuable insights so that we can make our decision making in a faster manner. Generally, all the manufacturing industries will have one common one common tagline or one common motive, that is to improve the productivity and reduce the cost or operational cost or maintenance cost on the day-to-day activities. So in order to enable that one, there are multiple technologies that has now come across, the multiple technologies have been evolved and came into existence. One is such as Industry 4.0 that covers the complete digital and automation setup. So specifically now we can focus on what is this automation, and assembly lines is one of the very crucial and critical elements in all manufacturing industry. Every industry will have an assembly lines. They will be used to for assemble multiple components, whatever the products may be or whatever the industry verticals may be. There will be assembly line. With now recently all the assembly lines are equipped with conveyors. And then how it is equipped, or how the assembly line is integrated seamlessly with other systems. And then the takt time of the assembly line is also one of the crucial elements. Like our products, every three minutes one product should come out, or every 5 minutes one product should come out. So likewise, industry themselves have set some standards or target of the takt time, and they are working accordingly. But in order to improve that one, or in order to increase the productivity of the assembly line day by day, and to also to reduce the dependency on the manual efforts, so this kind of assembly line automation is now very crucial and very critical, and also very essential also nowadays, because and we are in the Industry 4.0 revolution. So we are talking about lot of sensors, lot of hardwares that we are connecting to get the data, and also these robots and cobots came into existence. So how these can be used so that it can help us to improve our productivity, and also to meet our targets, and also to keep the quality up, always up to 100%. So these are some of the various critical factors that will decide upon to go for this assembly and automation. So before going into this one, I would just like to quickly touch upon how the assembly line has evolved over the period of time. So if you go in the very beginning, early stages of assembly lines, as far as I think it's a bit very far behind, like in the 12th century, there were some assemblies, the assemblies have started that time itself. And one example they have quoted is on the Venetian Arsenal, the ship assembly line. So that they used to move manually the ships in the canal, and while moving of the ships from one stage to another stage of the canal, they used to insert the parts, and then people will be assembling the components, and then the ship will be coming out at the end of the canal. So it was very fast, and also they were able to produce or assemble one ship in a day. So that was in early stages. Then Eli Whitney is the one who introduced the interchangeable parts in the terms of where the parts can be replaced in a complete set of component, or in a complete set of assembly. By interchanging some of one or two components, we can go to the next variance of a particular part. This was first introduced in firearms category, where mostly on the rifles and other defense, mostly on the machine gun side and the rifle side, where they introduce the interchangeable parts. So while the assembly itself, they will be changing one or two components, and then it will come into a new variant. So that is what it was, the next leap or next evolution of the assembly line. Then Ransom Olds is a person who introduced or he created or patented the assembly line concept itself in 1901, where they can able to complete the assembly line process. He patented it and he used for their car manufacturing assembly, and the productivity of that one is very much higher. So if you can see that almost it increased to 500 percentage in 1 year itself, the complete assembly line automation. So that is how that is introduction of this assembly line started in that particular era, 1901. And then Henry Ford came into picture and they introduced the conveyor lines that can still fasten the assembly line process. So that we can say the first level of automation started there, where the conveyor lines came into existence, and the components will be keep on moving in the conveyor line, and the people will be assembling the required elements in the particular stations. At the end of that conveyor line or end of the station, we will get a complete assembled product. In this case, it's the car will be completely assembled and it will be coming out of the conveyor line. So that is the next stage of assembly line evolution. And now we are in a stage where this mass production robotic age is in what to say is in existence, that the people are going for the mass production, and the robots and cobots came into existence. How we can use them for our particular assembly line and automate the existing process. So far all the manual process has been done with a lot of manual workers, and also quality of that particular assembly and sub assembly has been tested manually, and then it has been packed and dispatched manually. So there are a lot of manual works involved, and today's era, in this introduction of industry 4.0, and then data driven manufacturing, and then the quality driven manufacturing, everything is in the terms of 4.0 concept, like industry 4.0, quality 4.0, lean 4.0, automation 4.0. So everywhere we are talking about these terms, how it can be digitized, how it can be automated, how one factory can run seamlessly without any manual intervention. Then they call it as a lights out factory. That's a concept that is discussing also how the complete factory or assembly line can be running without any human intervention. So that is that current era that we are currently in. So this slides just give you a picture of how the assembly line has been evolved over the period of time there. And as I said, there are completely manual assembly lines. So what are the major difference between manual assembly line? So manual assembly line are slower and less accurate than automated assembly lines. So they require more manpower, where the automated assembly lines are faster than more accurate because it is fully driven by robots and cobots and machinery. So it's again a set of programs that will be being executed repeatedly. So the chances of errors will be lesser compared to the manual assembly lines, and they also require lesser manual power compared to the manual assembly line, so which can save money under the longer run. But on the other side, if you see, yes, automated assembly line on the initial investment side, it requires a lot of investment, because the complete set of stations and this thing has to be completely automated with lot of automated solutions like robots, cobots, AMRs, and the special purpose machines. So everything that will help us to form a complete automated line will be should that be to set up there, and the time might be little bit more longer to set up this automated assembly line. But as we have seen that benefit wise, once if we have crossed that initial hurdle of setting up the complete automated assembly line, then our productivity or quality will be much higher compared to the manual assembly lines. And what are types of automation that we can see in assembly line? So this slide speaks about that one majorly. So first one is the robots. So robots are widely used in the assembly lines. Majorly it is used to pick heavy components where safety is a major considerations there. So we don't want to have manually people picking up the heavy metal parts and then inserting into the machines or keeping in the assembly line. Considering one of the major considerations is safety, and also as well as the time on which the takt time or the productivity time or the setup times. Considering all these times, these robots are used widely in most of the industries, especially in the automotive industries and other aerospace industries, to lift huge components and assemble it and then to take it forward. That is one type. That is a part of this automation system in the assembly line. Then the special purpose machines also now came into existence, where in the complete set of assembly there are 10 stations. So out of these, 2 or 3 stations can be a special purpose machines which will dedicatedly do a certain sort of activities, say, like saying that a gluing of a particular components, or fastening the systems. So likewise, there are special purpose machines which can be introduced in the assembly line that will improve the automation efficiency of the particular assembly line. The third element is the introduction of the AMRs. AMRs is nothing but the autonomous mobile robots. The primary difference between AGVs and AMRs, earlier AGVs used to be there, that is automated guided vehicles in the factories. Automated guided vehicles is, as the name indicates, it needs a path or it needs a strip to guide that particular vehicle to move along the factory shop floor. So everywhere when the where that AGV has to move, there should be a mandate strip or some kind of a layout has to be there. So the AGV will follow the particular layout, and it will be used to pick and place certain materials from one place to another place. But now AMRs has been introduced where this will be completely working on the LiDAR and navigation-based technology. So there are no mandate strip required. Once user selects a start and end location where the material has to be picked up and it has to be delivered to a particular location, this AMRs will do this particular job specific. It will do without seamlessly without any intervention. In the assembly lines, majorly moving of the materials from one conveyor line to another conveyor line, or one station to another station, that particular movement of the materials between the assembly lines can be completely automated with the help of the AMRs. The next automation obviously is the industrial IoT technologies, where we'll be connecting all the assembly lines and we'll be calculating the OLEs, that is overall line effectiveness, and the quality and the productivity of the line, and also the complete traceability of the particular components can be enabled. Like when this component, what are the bill of material of a particular part or a product, where it has been assembled, by whom it has been assembled. So it is very easy now for the what is that manufacturers or the line HODs to easily track back when a component is assembled, by whom it has been assembled, where it has been assembled, so that if there is any defects, they can easily track back and try to correct the original root cause of that particular defect. So this is where this IoT plays a major and crucial role in this complete assembly line. And the last one is the cobots. Cobots are similar to robots, where the cobots are used to handle much lighter components, and it can interactively work with humans. Like it will like whatever the human will be doing in assembly, like opening the door or closing the door, and then picking up a part and then closing, and then again inspection of that particular part, and then putting a part in the required bins. So all these kind of activities which will closely be done along with a human, it can be easily collaboratively work with a human. So only it is called as collaborative robots, which is nothing but the cobots. So these are some of the major elements in the automations, or we can say major components that contribute to the automation in an assembly line. So coming to this, I think the same this would have you would have seen in yesterday's discussion also, where Mr. Karthikeyan would have presented about this autonomous industry transformation maturity model. Every industry has this transformation maturity model. Similarly, we have the transformation index for digital industrial IoT implementation as well, where there are 6 stages of implementation for industrial IoT. Where for stage 1 and 2 will be computation connectivity. Stage 3 will be visibility, then transparency, predictability, and then adaptability. So these are 6 stages in the industrial IoT or digital level. Similarly, in the automation or autonomous industries, there are a maturity model, or there are levels for which the factories or the industries can assess themselves currently in which level we are. And in order to move to the next level, what are the technologies or what are the improvement ideas that we should bring into our industry, so that we can able to move up the ladder in this autonomous maturity model. So if you can see there on x-axis, it will be the degrees of control intelligence. That is how much with how much intelligence the particular operations can be controlled, whether a manual intervention is required or completely the machine itself can take care of the complete operations. Even in the case of any anomaly has been detected, the machine itself can able to identify the particular root cause and able to give the or suggest the proper recommendation actions for that particular anomaly. So that is the degree of control intelligence which we wanted to traverse across this the maturity level. Similarly, the y-axis, if you can see, there will be degree of automation. Likewise, level 0 will be completely manually operated. Level 1 will be it will be basic processing of the workpiece inside the machine, and then level 2 where the cobots will be there to pick and place the machine. Level 3 where AMRs will be introduced, and level 4 will be something like the complete operation will be itself autonomous, and then level 5 will be, or the last level will be the flexible transportation for the complete value chain of our products. So these are the levels of maturity levels for autonomous. I think most of the industries currently, as per our experience, they lie in either level 0 or level 1 as of now, because this autonomous or the complete autonomous factory is now slowly, for many people or many organizations have started giving more focus on, so that now we can start thinking of thinking for us also, like currently where we are in autonomous level, and in order to move to the next stage of autonomous level, what are the technologies or what are the solutions that we can implement or adapt. So this it's a Berger manufacturing autonomous level. It is introduced, I think it has been given by Roland Berger. I think similar to Gartner, they are also introducing many industrial maturity index levels for autonomous solutions. And coming to this Lean 4.0 concept, how this assembly automation again plays a critical role in this Lean 4.0. Actually, Lean is nothing but eliminating of the waste. So where all our waste elimination mechanisms like value stream mapping, just-in-time, Kanban, Kaizen, POKYOK, everything will be coming into picture. And how these all can be converted, or how these all can be adapted into the complete assembly line automation is something that we need to take or consider also while implementing the automation system for the assembly line. For example, in terms of value stream mapping, where we need to completely map or process the streamline the process of how the complete process is flowing, and what is the takt time between one station and another station, how to reduce the changes or waste between a station to station. That is where the more the value stream mapping will be focusing on. And Kanban is something like having the right material at the right place at the right time is a major concept of Kanban. And POKYOK doing everything first time right, and Kaizen is something, a small improvement that we can do step by step. So all these put together, we wanted to have a complete, or while designing our assembly line, we need to consider all these factors and then implement this Lean 4.0 concepts into automated assembly line. That will help us to what to say, increase our productivity as well, and also to eliminate the waste which is contributing to the more lead time or more cycle time for our assembly components. So coming to specific use cases which we are going to discuss in today's session, I've taken three major use cases. So one is the individual assembly stations, where many of us would have seen there will be one machine, and people will be assembling the parts there, and then it will be moving on to the next station. It won't be in a sequence, but it will be individual stations there. And second use case will be the assembly line itself, where there will be a proper conveyor moving, and then in this case, a conveyor also will not be there, where the components will be shifted from one station to another station. Like out of 20 stations, it should come across all the 20 stations in order to have a finished component. So that is where this assembly line will come into picture. And the third use case is that even the building automation also is now becoming more crucial and critical, where the manual welding of most of the heavy equipment is taking place. So how to automate that one, and how to bring that into the assembly process. So these are the particular use cases that we have considered here. And the major challenges for individual assembly station is again for heavy parts movement, especially in the industries like off-highway truck manufacturing industries, or in aircraft or aerospace industries. They'll be having a huge components of how that can be moved and easily assembled, and then how this operations can be made more efficient by eliminating the waste. And similarly for assembly line, there will be productivity challenges. As I said, the takt time should be there, and the line balancing issues will be there, where the load on one line will be more, the load on one line will be less. So how to manage that line balancing issues. Similarly for welding automation, it prefers, or it focus more on the quality of the welding, what we are doing and how we are doing. So how we can be implemented by using cobots and then the complete robots and assembly cobots, and for assembly line introduction of the conveyor lines as well, and the introduction of the robots and cobots in specific areas, so that the manual intervention can be completely eliminated. Again, for welding automation, introduction of the high accuracy welding robots where the quality and the time cycle time can easily be achieved there. So these are some of the use cases which I'm going to just explain detail, like use case one, how the assembly station can be done here. Say for example, this is like kind of an future state, not in the current manual state. Assume that currently everything is being done manually. So how that manual operations can be converted into an autonomous operation or autonomous assembly line. So this is assembly station where heavy components will be taken place and it will be kept, and it will be assembled there. So this robots will be used to pick up the heavy components from this Kanban rack, and it will be placed in the assembly station. And then the cobot will be used to actually do the specific particular operations there. And all the required safety sensors and the safety gates will be presented there, or will be located there, so that every operations will be what is done with a specific level of safety, and the complete assembled products will be again kept in the assembly product bin, so that it can be easily taken to the next level. So this, if you can see, this operation is completely autonomous here. There is no manual intervention. Just the robots and cobots need to be programmed accordingly in order to pick up the material, and then what is the set of sequence of operation that has to be done in order to assemble a particular component, and also for a particular product. And then again, once the product is finished, and then move to the particular, that particular product can be moved to the finished goods. So where the inspection of that particular product will be taken place, and then it will be going to the dispatch. And how to make this as a complete closed loop system is something the right hand side picture talks about, where the data from these cobots and robots will be continuously being transmitted, and it can be continuously monitored there. And if at all there is any issues, or if there is any the productivity loss has been recorded, or the line is down for some other reason, so that can be completely monitored, and it can be given with the proper alerts and notifications to the respective users, and the time bound action can be immediately taken, so that this will form a complete closed loop system by having the required data from this from this automation system. So again, the major benefits that we are going to get is complete workflow will be managed digitally, and integration between the process is achieved with a high degree of accuracy, and the required analytics, since it is all the data has been captured, we will get the required insights to improve the efficiency of this assembly station. And this was the recommended, in order to implement that particular assembly station, what are the recommended system or the components that we require: a robot arm and the cobot, the robot HMI panel, robot control unit, the end effector for picking up the parts, and the robot stand, and the workstation PC. These are some of the major components that is required in order to enable that particular autonomous assembly station. So how the user journey will be there compared to the previous manually working assembly station to the completely autonomous assembly station is something depicted here, where the particular initial step of part gathering will be done by the robots, and assembly will be done by the cobots, and then the part storage again will be done by the robots and cobots. It will be stored there, and the material parts movement from one place to another place, it will be achieved by the AMRs. So this is a complete set of automated assembly stations where there is no manual intervention required. Maybe some degree of intervention is might be required in this place, where the materials can be picked up and placed in the AMRs to go there to the required station. But that also can be automated easily now with the AMRs, along with the cobots is also coming into existence, where the cobots will be placed on top of AMRs, and it will be used to pick and place a particular material there. So this is on the first use case. The second use case speaks about the complete assembly and automation itself. As I said before, the first use case primarily focus on the individual machining stations where the components are assembled there, and then it can be picked up and placed. Where this is a complete assembly line. I imagine around 20 stations are there. A round conveyor line can be enabled there, and then there will be multiple sub-assembly stations. So in order to have that multiple sub-assembly stations connected to the main assembly stations, this material transfer AMRs can be introduced in order to achieve that particular this thing. And then the material movement conveyor is there, where the conveyor is enabled there, and the conveyors will be keep on moving on that, the materials will be moving on to keep on moving on the conveyor from the sub assembly line. From the sub assembly lines, the components will be transferred to the main assembly line. Again, the main assembly line conveyor will be completely automated, and each and every stations will be equipped with the robots and cobots to do the particular set of operation. Of course, if you can, it depends upon the various industries as well, where we can achieve 100-degree automation, or 90-degree, or 90 percentage, or 80 percentage, depends upon the or what kind of operation that they are doing in the assembly line. So in the case of automobile industries, it is very much capable, or very much possible to achieve 100 percentage assembly automation, whereas in other industries like maybe the healthcare industry, where they produce very critical or intrinsic components, we can achieve up to 80 degrees or 70 degree of 70 percentage of this assembly automation. Again, the last stage, even the quality inspection stage, can be bought into this automation line, where the AMRs will be, the cobos will be equipped with the machine inspection camera, and it will inspect the components in that assembly line itself, and then it will detect the failures of the components there, and then the reports will be recorded, and then it will be placing the respective components in the past or failed category accordingly. So the quality of that particular product or components also will be ensured on the each assembly stations. So again, the major benefits will be the line balancing will be achieved, where demand to the capacity will be always be intact, and the workflow will be seamless. And also this can be integrated with any other systems, like any other enterprise system, like our SAP systems or inventory system, so that our complete operation itself is streamlined there. So based upon the our master scheduling, the assembly lines can operate, and based on the inventory schedule, our assembly lines can operate, and our robots or cobos or AMRs can act accordingly, so that the complete end-to-end process can be streamlined. And here also the streamline closed loop system is enabled by capturing the data at each stations, and also the end of the line, the capturing the quality data, and then these data can be used for getting the required insights, so that we can have our decision making process in a much faster way. So again, to enable the system, the recommended components are the belt conveyor for the material movement, cobots for the assembly, and robots in the HMI panels, in defectors. And also we require the PLC so that it can be easily controlled, and also conveyor controls the HMI, mainly for the user interfaces. So these are some of the recommended components to enable the system, and how the user journey will be looking like for this automated system. So initially sub-assemblies will be done by the cobots, and the material will be moved from the sub-assembly to the main conveyor line by AMRs. So there again the cobots or robots will be used to complete finish the complete assemblies there, and the main assembly will be finished there, and then it will be moved to the inspection system, where with the help of machine vision based cameras, inspection can be done, and then the material will be moved to the finished goods location with help of AMRs. So here also we are trying to achieve the complete autonomous system without any manual intervention. And third use case is pretty much straightforward, where the welding automation is also taken into consideration. So this welding cobots is now very much popularly used there. So in our case, if our assembled components need any set of welding or laser welding, so this welding station can easily be enabled there without the manual intervention there. So only if you can see non-value elements or non-value activities can be reduced here, and the waste can be completely or totally eliminated here. So this is a system again recommended for this one. Welding robots and material handling robots is there, and vision systems to check the weld quality, and the software for the vision system can be enabled, so that the complete the quality check can be done on that particular platform as well. So this is the user journey for this welding, where the parts will be transferred automatically, and then robot will start the welding there, and then the parts will be transferred to the inspection system. Inspection will be done, and it will be moved to the finished goods sections. So this is the complete intelligent closed loop system architecture for this autonomous autonomous factories, where our systems can be integrated right from the job card, where the job has been assigned to a particular machine or assembly station. So based on the particular scheduling, that vehicles, the AMRs will be there to pick up the material from the inventories, and it will place on the particular assembly lines or the conveyor lines. The robots and cobots will do the specific assemblies, and then the AMRs will be used for the material movement transfer, material movements of the finished goods or the semi-finished goods. So complete process is being integrated, and then everything it will be controlled by the PLCs, and it will be constantly communicating to the industrial IoT devices, industrial IoT platform, so that the complete set of automations or the complete set of process can be monitored at each and every time. So this is where this closed loop system is much more beneficial itself. Since the data are coming regularly, the real-time data, it will be helping the users to take that decision very instantly, and they can able to correct the system, and then they can ensure that the system is running seamlessly without any manual interventions. And these are some of the safety standards that is being introduced. I think yesterday also would have seen this one. Some of the ISO standards being followed by the industries, and the safety fence, and also for the movement, there will be certain set of ranges where the humans can go in order to ensure the safety or or interaction with the automated systems there. So this is a typical manufacturing scenario where right from the raw material storage till the logistics, how the automation system can be enabled. So from the raw material stores, the materials can be moved to help with to the machining station with help of AMR. So cobots will be placing that particular components into each machines, and the assembled goods will be again taken by the AMRs to the assembly area, where assembly area will be completely automated with help of robots, cobots, and the conveyor lines. The complete set of assembly will be running there. And once the finished goods is there, then the AMRs will be taking the comp to the finished goods automatically. From there, it will be moved to the logistics there. And this complete set of operations will be controlled or monitored by the fleet management system, where the continuous movement of the AMRs can easily be detected, and also the cobots and robots also can be integrated into the fleet management system to monitor their complete continuous operations there. So this is a typical manufacturing scenario to depict the usage of AMRs and cobots and robots inside the manufacturing industry. And this is the implementers approach, like how we will implement the system. So different industries will have different requirements on level of automation which they want to achieve it. So for gather the particular requirements, and then design the system accordingly. And before going for this particular implementation, we will do a small set of simulation, how that particular assembly line will be looking like. And then once it is approved by all the stakeholders, then go for the procurement of the particular components. And then we will be fifth step will be the fabrication assembly of the entire system, and then testing of that one particular system, and then the field testing. And then once after implementation, the support process will be continuing. So this is a major implementation approach that will be followed for any assembly and automation system. The major benefits that we are recognizing is improved production efficiency, product quality is improved very much, and the cost is very much reduced. And also, the say one of the critical aspect is the safety of the workers or safety of the employees is very much ensured in this particular automation assembly line. So this is something I want to finish my slides with this one to show how the future of factory will be looking like here. So if you can see, this is maybe a vision like how the future factory will be looking like, where all the material movements will be done with the help of the AMRs, and all the analytics part will be displayed with the real-time data from the systems, and the robots and cobots will be there inside the shop floor to do all the assemblies, and then what is it, inspections, and then packaging and dispatching. Everything will be done by that particular robots, cobots, and AMRs inside the shop floor. So this is envisioning, or this is a vision for the future factory, how it will be looking like. So with this, I have a small set of video demos. Like this is one example for battery cell assembly, like how that has been completely automated without any manual intervention there. So this set of conveyor assembly lines, and we will be using this cobots to pick and place the particular components and into that particular battery cell assembly. I'm having one more other video here. Just I'll play that one, where it will show how this complete. This is a kind of a riveting system mechanism where you can see that there will be a bowl feeder in order to segregate the parts, and then there will be a system. This is a kind of a pick and place code for that particular assembly. The components will be picked and placed in a particular station. Yeah. And then the cobots will ensure that the recommended operations are done there. So slightly bigger components can be assembled with help of the cobots there. Yeah, the actual riveting process again is done with help of cobots. Top checking is being done there. So once at the end of the line, the automated marking system also will be enabled to automatically mark that particular component or the part number in that particular workpiece, and then it will be moving to the dispatch packaging area. So this is shows the complete efficient end-to-end automated assembly line here.